Hi science students. In this video we're going to discuss what is probably the most famous of Newton's three laws of motion, the third law of motion, which states that for every action force there is an equal in magnitude but opposite in direction reaction force. Now this third law of motion and its definition have really become what we might call a colloquialism, where people will state for every action there is an equal and opposite reaction and apply that theory to all sorts of different aspects of life in general. But the actual definition as it stands is about forces, and it talks about the magnitude of the force and the direction of the forces that are involved. We're just going to discuss a few different situations and how Newton's third law pertains to those. So I'm going to go to this slide here, which is right near the end of the notes. I'm just going to talk about a few situations, the forces that are being exerted and the reaction forces that are occurring as a result. So here we have a person with their foot on the ground, and they are pushing on the ground in order to get some purchase and lift themselves up. Looks like they're going mountain climbing or something like that. So in this case, the action force is person's foot pushing on the ground. Now, in reaction to that, the ground will push back up on the person's foot with equal magnitude but opposite direction. Next example here, a water rocket. Now, with a water rocket, you may be familiar with the workings of these. You seal the rocket, so there's water sealed inside the rocket, and then you apply a pump, or just an air pump, which pumps air into the bottle with the water and creates an enormous amount of pressure, which eventually must be released. So what happens as an action force is that water is pushed out by the pressure that's in the bottle. So I suppose in a way we would say that the bottle's not really pushing on the water, but the pressure inside of the bottle is pushing the water outside or down and out of the bottle. So we'll just sort of keep it simple. We'll say that water is being pushed downwards. Now, as a reaction force to that, the water will push back up on the rocket. A hot air balloon. Now, in a hot air balloon, the person operating the balloon will create some heat down here, right near the bottom of the balloon. That heat leads to some hot air being released inside the balloon, and of course that creates an upwards thrust because warmer air will rise. So we have air pushing on the inside of the balloon is our action force. So air pushes on balloon. Hot air pushing on the balloon. And as a reaction force to this, actually I might change it to a black colour here so we can see it against the red balloon. The balloon pushes on that air. So identifying action and reaction forces is usually relatively simple. I just want to go through one more with you guys that's not on this page. Just going to draw a quick little sketch of little curve here. I'm going to make this as the Earth, right? And just a very simple sketch of the Earth. Now I'm going to get this color because this is a rock. Okay. Now this rock is falling towards Earth. So what is the action force and what is the reaction force for a rock falling towards Earth? Now this is often a tricky one to identify. Or the action and reaction forces can be tricky to identify for this sort of situation, but it's one that's typically asked in test and exam situations. Well, the action force is the Earth pulling the rock towards it due to gravity. So Earth pulls rock just due to gravity. Now, what is the reaction force? Well, in fact, believe it or not, the rock pulls the Earth. Okay, so when something's falling towards Earth, like let's say, well, even just for you, not necessarily falling, but you yourself, your body is being pulled towards Earth when you're on the Earth, and your body is pulling back on the Earth. Now, because of the huge difference in mass, the pull of these smaller objects on the Earth is imperceptible. It's highly perceptible when we drop a rock because we can see it fall towards Earth. That force is very perceptible, but the reaction force is basically imperceptible because of the massive mass of the Earth. Okay guys, thanks for watching. Go ahead and try some of the questions that are in the description for the video.